The next category of behavior we are going to discuss in relation to process model is the integrating process. Earlier video we have discussed about the self-regulating process and also the non-self-regulating process. So the integrating process is also known as non-self-regulating process, but usually it is easier to represent the process as integrating rather than non-self-regulating process. The integrating process is one of the type of the process that do not have steady state gain. For example, an integrating process, or the name comes from integrator, has the following transfer function, which is ys over us equivalent to k over s. So k is a constant and s is the pole of the transfer function. So if we consider a step change of magnitude m, then the us is equivalent to m over s. Therefore, if we multiply or if we include us into this equation, what we have is the output equation ys, which is equivalent to km over s squared. By inverse Laplace transform, we can get yt is equivalent to kmt. This is obviously a linear function with ramp behavior. Therefore, yt is unbounded. If we put any signal to the system, the response will increase as the time increases, because this equation has t function over here. So that is why we call it unbounded, and a new steady state value does not exist. So this behavior is not similar with the transfer function we discussed earlier, which is of self-regulating process. So the integrating process, the behavior is unbounded.